Yes, the wireway of a panel having a nameplate rating of 208Y/120 volts can be used to run branch circuit conductors through from a 480Y/277 volts panel, provided certain conditions are met. Firstly, voltage compatibility is crucial. The wireway itself must be rated for use with the higher voltage of the conductors passing through it, which in this case is 480Y/277 volts. The conductors that are run through the wireway, regardless of which panel they are serving, must have insulation that is rated for at least 600 volts. This ensures that the insulation can withstand both the low voltage of the 208Y/120 volts panel and the higher voltage of the 480Y/277 volt source panel. Secondly, proper color coding is essential for safety and identification. The conductors must be color-coded to clearly identify the circuit voltage. A common color code for 480Y/277 volt systems uses red, white, and blue for the phase conductors and neutral respectively. For 208Y/120 volt systems, a typical color code is black, yellow, and red for the phase conductors, with white for the neutral. Always verify and adhere to any locally mandated or facility-specific color coding standards. Thirdly, the branch circuits passing through the wireway must be protected by overcurrent devices, such as circuit breakers or fuses, that are rated for the higher voltage, which is 480 volts in this scenario, supplied from the source panel. This ensures that the overcurrent protection is adequate for the voltage level of the circuits being protected. Fourthly, the wireway itself must be clearly marked to indicate that it contains conductors with different voltage ratings. This warning helps prevent accidental contact or improper work practices. The marking should be readily visible and easily understood by anyone accessing the wireway. In addition to these key conditions, there are some additional considerations to keep in mind. The wireway should be large enough to accommodate the additional conductors without overloading it. Overloading a wireway can lead to overheating and potentially dangerous conditions. The National Electrical Code, or NEC, provides guidelines on wireflow capacity for wireways. The wireway should also have sufficient ventilation to prevent overheating. Proper ventilation helps dissipate heat generated by the conductors and ensures that the wireway remains within its safe operating temperature range. The wireway should be installed in a manner that minimizes the risk of accidental contact with the conductors. This includes ensuring that the wireway is properly grounded and that any exposed conductors are adequately insulated or guarded. Adhering to these conditions allows the wireway of the 208Y/120 volts panel to be used to run branch circuit conductors from the 480Y/277 volts panel safely and in compliance with electrical codes. Always consult with a qualified electrician or electrical engineer to ensure that all applicable codes and regulations are followed. Understanding voltage compatibility is paramount. Electrical systems operate at various voltage levels, and it's essential to ensure that all components within a system are rated for the voltage they will encounter. In this case, a wireway must be capable of handling the highest voltage present, which is 480Y/277 volts. The insulation on the conductors must also be rated for at least 600 volts to provide an adequate safety margin. Color coding is not just a matter of aesthetics, it's a critical safety measure. Consistent and standardized color coding allows electricians and other personnel to quickly and easily identify the voltage and function of different conductors. This helps prevent accidental contact with energized circuits and reduces the risk of electrical shock. Overcurrent protection is another fundamental aspect of electrical safety. Overcurrent devices, such as circuit breakers and fuses, are designed to protect circuits from excessive current flow, which can lead to overheating, insulation damage, and even fires. The overcurrent devices must be rated for the voltage of the circuit they are protecting. In this case, the branch circuits passing through the wireway must be protected by overcurrent devices rated for 480 volts. Proper marking of the wireway is also essential for clear communication and safety. The marking should clearly indicate that the wireway contains conductors with different voltage ratings, alerting personnel to the potential hazards. The markings should be durable and easily visible, even in low light conditions. When determining the appropriate size of the wireway, it's important to consider not only the number of conductors but also the size and type. The NEC provides tables that specify the maximum number of conductors that can be installed in a wireway of a given size. It's also important to ensure that the wireway is properly supported and secured to prevent sagging or damage. Ventilation is another important factor to consider. Heat generated by the conductors can build up inside the wireway, potentially leading to overheating and insulation damage. Providing adequate ventilation helps to dissipate this heat and keep the wireway within its safe operating temperature range. The specific ventilation requirements will depend on the size and type of the wireway, as well as the number and size of the conductors installed within it. Minimizing the risk of accidental contact with the conductors is a key safety objective. This can be achieved by ensuring that the wireway is properly grounded, that any exposed conductors are adequately insulated or guarded, and that the wireway is installed in a location where it is not likely to be damaged. The NEC provides detailed requirements for grounding and guarding electrical equipment. Adhering to all applicable codes and regulations is essential for ensuring the safety and reliability of electrical systems. The NEC is the most widely adopted electrical code in the United States, but it's important to be aware of any local codes or regulations that may also apply. Always consult with a qualified electrician or electrical engineer to ensure that all work is performed in accordance with applicable codes and standards. In summary, running 480Y/277 volts branch circuit conductors through a 208Y/120 volts panel wireway is permissible under specific conditions. These conditions include voltage compatibility, proper color coding, adequate overcurrent protection, and clear marking of the wireway. It's also important to consider the size and ventilation of the wireway and to minimize the risk of accidental contact with the conductors. By adhering to these guidelines and consulting with qualified professionals, it's possible to safely and effectively integrate different voltage systems within a single wireway. Always prioritize safety and compliance with applicable codes and regulations to ensure the integrity and reliability of electrical installations. In addition to the points already covered, let's delve further into some specific aspects. When considering voltage compatibility, it's crucial to understand the difference between the voltage rating of equipment and the actual voltage present in a system. Equipment is typically rated for a maximum voltage, and it's important to ensure that the actual voltage in the system does not exceed this rating. In the case of a wireway, it must be rated for at least the highest voltage present, which in this case is 480Y/277 volts. However, it's also important to consider any potential voltage fluctuations or transients that may occur in the system. These fluctuations can temporarily increase the voltage above its nominal level, so it's prudent to select equipment with a voltage rating that provides an adequate safety margin. Color coding, while seemingly straightforward, can sometimes be a source of confusion. Different jurisdictions and facilities may have their own specific color coding standards, so it's important to be aware of these variations. In some cases, color coding may be mandated by law, while in others it may be simply a matter of best practice. Regardless of the specific color coding scheme used, it's essential to ensure that it is consistently applied throughout the entire electrical system. Overcurrent protection is a critical aspect of electrical safety, and it's important to understand the different types of overcurrent devices available. Circuit breakers and fuses are the two most common types of overcurrent devices, and each has its own advantages and disadvantages. Circuit breakers are resettable, meaning that they can be tripped and then reset, while fuses must be replaced after they have blown. The choice between circuit breakers and fuses will depend on the specific application and the preferences of the installer. The marking of the wireway should be clear, concise, and easily understandable. The marking should indicate that the wireway contains conductors with different voltage ratings and should also specify the voltage levels present. The marking should be durable and resistant to fading or damage. It's also a good idea to include a warning symbol or message to further emphasize the potential hazards. When sizing the wireway, It's important to consider not only the number of conductors but also their size and type. Larger conductors will require more space in the wireway, and certain types of conductors, such as those with thicker insulation, may also require additional space. The NEC provides detailed tables that specify the maximum number of conductors that can be installed in a wireway of a given size, taking into account the size and type of the conductors. Ventilation is essential for preventing overheating and ensuring the safe operation of the electrical system. The amount of ventilation required will depend on the size and type of the wireway, as well as the number and size of the conductors installed within it. In some cases, natural ventilation may be sufficient, while in others, forced ventilation may be required. The NEC provides guidelines on the minimum ventilation requirements for wireways. Minimizing the risk of accidental contact with the conductors is a key safety objective. This can be achieved by ensuring that the wireway is properly grounded, that any exposed conductors are adequately insulated or guarded, and that the wireway is installed in a location where it is not likely to be damaged. Grounding is essential for providing a safe path for fault current to flow back to the source, tripping the overcurrent device and preventing electrical shock. Insulation protects against direct contact with energized conductors, while guarding provides a physical barrier to prevent accidental contact. Adhering to all applicable codes and regulations is essential for ensuring the safety and reliability of electrical systems. The NEC is the most widely adopted electrical code in the United States, but it's important to be aware of any local codes or regulations that may also apply. These local codes may be more stringent than the NEC in some cases, so it's important to be familiar with the requirements in your specific jurisdiction. Always consult with a qualified electrician or electrical engineer to ensure that all work is performed in accordance with applicable codes and standards. By carefully considering all of these factors and following best practices, it's possible to safely and effectively run 480Y/277 volts branch circuit conductors through a 208Y/120 volts panel wireway. Remember, safety should always be the top priority, and it's important to consult with qualified professionals to ensure that all work is performed in accordance with applicable codes and standards.